Hello, welcome to chapter 10, and in this chapter we're going to look at a few more JVM flags that we can use to tune the memory settings of our virtual machine to optimize its performance as our application runs. I think we'll start this chapter by picking up actually where we finished in the last chapter, where we learned about the string pool. The way that the string pool is implemented is by using a hash map. Now we are going to look in a bit of detail about how hash maps work later on in the course. So for now, I'm going to simplify things a little just so that we can focus on tuning the memory part. We'll go into more detail about hash maps later on, so if what I'm about to say doesn't make complete sense just yet, don't worry, it will do when we've covered that part of the course. And if you already know about hash maps, well, please forgive me that I'm going to be giving a really simplified explanation at this point. So we can think of the string pool as being a set of buckets. Initially, if this was a standard hash map, there would be 16 buckets in the pool. Now, to keep things simple on screen, I'm not showing all 16. I think I've got 10 of them here, and they're numbered 0, 1, 2, 3, and so on. When a string is placed into the string pool in Java, what happens is that a calculation takes place which uses the hash code of that string, and that calculation determines which bucket within the string pool the string needs to live in. So for example, if we wanted to add the string mouse into our string pool, this would actually end up in bucket number 5. The string book would be in bucket 9, and the string chair would actually also be in bucket 5. Now again, how this works, how we know which bucket a particular string will be stored in, well, I'm going to go into more detail about that when we talk about hash maps later in the course. But the point we need to understand is that the strings that have the same hash code will definitely always be in the same bucket, but we can also have different strings in the same bucket as well. This way of working, putting the strings in buckets based on their hash code, is actually generally an efficient way of doing things. Whenever we want to add a new string into the string pool, what Java needs to do is check to see whether that string is already in that string pool. If it isn't, then it can add it. Searching through every string in the pool to see if it already contains the same content as our new string could take quite a lot of time. So rather than doing this, what Java says is, well, if our string is already in the pool, which bucket would it be in? And once it knows that, it only has to check the strings in that bucket to know if that string is there or not. If you know about hash codes, you'll know that two identical objects will always have the same hash code. So if the string is there, we know which bucket it will be in, we'll be able to find it. This means it's a much more efficient technique to find out, is this string already in the string pool, than having to look at every single string that could possibly be there. But there's one possible issue here, and that is the size of the string pool. And by that I mean how many buckets are there. A standard hash map starts with just 16 buckets, but it grows over time. And if the number of buckets is quite small and we have a large number of strings, then the number of strings in each bucket could be quite big. And the process of interning a string, checking every other string in the same bucket to see if that string is already there, would take quite a lot of time. It would be inefficient. If the number of buckets is quite big and we don't have that many strings, well, this could potentially also make things inefficient, although in reality, that's not normally that important. If we don't have that many strings, there's not normally any point trying to optimize the string interning process.